We recently talked about Azure Web Apps and Azure Functions. These are great tools, but typically when working with those, we need to have some sort of resource to store the data associated with the applications. One of the ways that we can do this is by leveraging Azure's CosmoDB. So let's start by learning about what CosmoDB is. CosmoDB is Microsoft's NoSQL non-relational database solution. The topic of relational versus non-relational databases is one that is beyond the scope of this course. But the underlying concept is that with a relational database is that you create structured tables with specific data. With non-relational databases, each record is essentially a document that could contain different points of data. You then present these to the application and let it filter them as needed. You can utilize different APIs or models to connect your application to Cosmos DB, which we'll talk about in just a second. It also provides the ability to scale throughput and storage to meet the needs of your application today and as it grows over time. With Cosmos DB being globally distributed, you can have your data as close to your users as possible, even if they reside in multiple locations. And as you serve your global users, the question always comes into play is how do you make sure your data is in sync? There are 5 different consistency options available so your Cosmos DB can meet your application performance and data consistency requirements. Cosmos DB gives us the ability to connect using a variety of methods. So if your application was designed to work with one of the following APIs, you can utilize Cosmos DB to store the data. This is not a final list, but is what Microsoft currently supports at the time of this recording. Core is the default. It's Microsoft's NoSQL solution, and it leverages the SQL API. It was previously referred to as DocumentDB. The MongoDB API allows you to leverage CosmoDB while using your existing MongoDB client drivers and SDKs. Cassandra is used for storing data for Apache Cassandra. The Gremlin API is used for storing graph data. And the Table API allows you to interact with data as if it was in Azure Table Storage. etcd API is useful as a backend store for Kubernetes. However, note it is currently in preview. Let's talk about the structure of CosmoDB. The database account is the first thing that we create. Some of the important items defined at the account are the consistency level, the global distribution, backup settings, and capacity type. Capacity type determines if you are going to use provision throughput or serverless, essentially reserved capacity or consumption-based. As part of the database account, we then define the API we are using. It defaults to core, but you can choose any of the ones we mentioned previously. We then create our databases, and here's where we define the throughput and request units, or RUs. An RU is defined as the compute needed to perform an operation. Typically it will cost 1 RU to fetch 1 kilobyte of data. To write that same data costs approximately 5 request units, or RUs. You can define a fixed amount of throughput here or have it set to auto-scale. Within the database, we then define our containers, and this is where we define our partition key. The partition key is what CosmoDB uses to group our documents together. We can see in the diagram how the account includes the databases and containers, and then you can see if within the database you can hold one or more containers. Within a container, we then create our physical partitions. A physical partition consists of one or more logical partitions, which we'll talk about in a second. An important thing to note with the physical partition is that they have a limit of 10,000 RUs per second. This means if your application is under 10,000 RUs a second, typically you're going to have one physical partition. Once you go above that, then you need to have more than one partition. If you configure your database to autoscale, Microsoft will automatically create the additional partitions for you. If you configure your database throughput to have a set number of request units, Microsoft will automatically provision the number of physical partitions up to that limit, but will not provision past that. If your application needs greater performance, then those requests will start to queue up behind that. All of the actions at the physical partition level are managed by Microsoft. You don't need to do anything in that regard. Logical partitions reside within the physical partitions, and they group documents by the partition key that we define in the container. Each document that has a unique partition key will have a logical partition in a 1-to-1 ratio. All documents that have the same partition key will be in the same logical partition. Each logical partition has a maximum size of 20 gigabytes. We'll need to keep this in mind when determining our partitioning key. There is not a limit for the number of logical partitions that can be created. If we look in the diagram again, we can see we've got our database and containers from the previous example, but now within that container, you can see we have a physical partition with multiple logical partitions within it. If you want to find out more information, we've got a link at the bottom to help explain this in greater detail. Now that we understand how the components of Azure CosmoDB work together, let's start by looking at a sample document. We have some generic data about a city. This one is specific to Chicago. So for this example, we use city as our partition key. For all documents in the same city, they will be grouped into the same logical partition. That means that for every document that is created that has a unique city defined, we will have a new logical partition. To put this in action, we've got our sample document. And as we add additional sample documents that have the city set to Chicago, you can see they'll group together to form a logical partition. As we add additional documents that include additional cities, we will have a new logical partition for Paris as well as San Francisco, or for every other additional city that we add. Here's another example that takes a look at it from a little bit bigger scale. Here we have two containers. The one on the left is using city as a partition key. The one on the right is using user ID as the partition key. We can also assume, since we've got two physical partitions in each container, that the throughput or RUs needed are between 10 and 20,000 a second. You can see we've got multiple logical partitions, each being associated by the city, since that is our partition key. On the right, you can see we've got different user IDs that are grouped together to form our logical partitions, again, since our partition key is set to user ID. Now that we've learned the basics of CosmoDB, let's jump in the portal and create an example. So here we are back in the Azure portal. We've got our Skylines resource group open up, and we're going to be looking at creating a Cosmos DB. So to start, let's go up to the search bar. Let's type in Cosmos, and you can see here we've got Azure Cosmos DB. So let's go ahead and open that up. You can see we don't have any Cosmos DB defined today. So let's go ahead and click on Add. And now we've got the very familiar screen at this point. Let's go ahead and select our resource group of Skylines. We're going to give it a name, so we'll just call it Sample Cosmos DB. We'll put JF on the end. Perfect. And now we define the API. So here you can see we've got a number of different options available. We're going to leave the default of core. We scroll down and we define our location, as well as our capacity mode, whether we're going with the reserve capacity or if we're doing a consumption based. And then finally we can scroll down to the account type. We've got production, non-production, and you can see if we switch the account type to production, it also configures multi-region rights as well as geo-redundancy. So let's go over to networking and we'll take a look here. You can see we can define our connectivity method, whether we're allowing open access, specific networks, or if we're only allowing private endpoint. We're going to go ahead and leave the defaults here, and then we're going to go ahead and select just the Skylines VNet and the default subnet here. You can see here we've got our backup policy. So we're going to back up every 4 hours. I'm going to retain that backup for 8 hours. So let's go ahead and move on to next to encryption, and then here we have the option of basically letting the Cosmos DB account handle the encryption, or we can do a BYOD and specify the key vault that contains the key that we're going to use for encryption. We'll leave the default right now of service managed encryption. We'll go to tags, and then we're going to go to review and create. And you can see we've got validation success here. We're going to do something slightly different this time. Rather than finish creating this in the portal, we're going to go to Cloud Shell and create this using Azure CLI. So to do that, I'm going to go up to the top right here, and we have the option for Cloud Shell right in the portal. So I'm going to go ahead and open this. And this is the first time you ran it, it's going to ask you to basically select a storage account. Since this has been open before, what I'm going to do now is I'm also going to hit this tab to open up a new session. So it's basically going to open this up in a new window for us. Now we've got a little more real estate where we can run our commands. So let's figure out what command we need to run in order to create a Cosmos DB using Azure CLI. So I'm going to open a new tab, and we're going to type Azure CLI Cosmos DB, and if we scroll down to the results here, you can see we've got the AZ Cosmos DB command. So let's go ahead and open that, and now you can see we've got a number of commands that we can run within Cosmos DB or as part of the Cosmos DB command. So we're going to look for create. So let's scroll down through our list. You can see we got a lot of Cassandra options here, collection, and then here we can see create. If we open that up, now you can see the command that we need to run in order to create a Cosmos DB database account, as well as the parameters that go along with it. And if you scroll down, you can see we've got a few basic examples, and it also goes through the required parameters as well as some of the optional parameters. To skip ahead a little bit, I went ahead and created a command that's going to go ahead and deploy our Cosmos DB database account. And you can see here we've got a name of Skylines demo account. We're putting it in the Skylines resource group. And the default consistency level is session, but in this case, we change it to bounded staleness. So with our max interval command, what we're essentially saying is since we're using the bounded staleness, we have a certain window that we can allow Cosmos DB to be out of sync. And with max interval of 300, that means 300 seconds or 5 minutes. So within 5 minutes, any information that's put into Azure Cosmos DB or written to Azure Cosmos DB will be available in all of the instances of that Cosmos DB. With the same concept in mind, we have configured the max staleness prefix parameter to 100,000. This means that we can have up to 100,000 updates to our database before Cosmos DB will force all instances to sync up. Whichever of these two thresholds is reached first between the max interval and max staleness prefix will determine the maximum lag time or lag threshold our Cosmos DB database account will have. And what we're also doing with this is we're deploying this Cosmos DB instance to multiple regions. You can see for the first locations parameter, we're pointing to West US2, and for the second locations parameter, we're pointing to East US2. So with that said, let's go ahead and let's copy this command. And now let's go back to the portal. Let's go back to our Cloud Shell instance, and let's right click and paste this, and go ahead and hit enter to let it run. This will probably take 10 to 15 minutes, so we're just going to sit back and let this run. We'll come back in a second to check the status. And here we can see after a little while that the resource did complete successfully. You can see we've got our new Cosmos DB instance. You can see we've got the consistency level set to bounded staleness with our settings. So now let's jump back into the portal. And we're going to go ahead and go home, go back to Azure Cosmos DB. We're going to quit the Cloud Shell. Here you can see our instances online. You can see we're reading out of both the West US2 and East US2, and our right region right now is West US2. Let's go ahead and open up our database account and start creating some databases and containers. You can see now that our database account is open, we've got our read locations as well as write locations defined, and we can scroll down on the left, and now we can go to containers. Let's go ahead and browse. You can see we don't have anything in place there today. We're going to go ahead and add one. And then you can also see now that it is using the SQL API because that is what we defined when we created our database account. So we're going to go ahead and define our database ID now. We're going to use DemoDB. And now we can define our throughput. Again, you can define this to autoscale or you can set it to manual. We're going to leave ours with the default of 400 because we don't anticipate really a lot of activity with this database, being it's just a demo. Now we're going to go ahead and define our container. So we'll just call this one demo container. And now we get to the partition key. If we remember back from the PowerPoint, the partition key is how we define how the logical partitions are segmented. And from the examples there, we use city as our partition key, so we're going to go ahead and use that as well this time. So /city. So let's go ahead and we're not going to define anything else here. We're going to hit OK. And then you can see kind of down at the bottom, we're going to go ahead and start creating that new database and also creating that container within it. We'll let this spin for a minute and we'll come back in just a second. All right, now we can see everything's been created. So let's go ahead and we're going to expand DemoDB. We're going to expand demo container. And within here, we can see we've got a few items listed as far as store procedures, functions, and triggers. We're not going to look at those quite yet, but we're going to go ahead and look at items. And if we expand this here, you can see right now we don't have any items in play. So now let's go ahead and upload an item. If we go up here to the top right and select upload item, we can go ahead and browse. And then we can see in our examples, we have the city file. So we're going to go ahead and select that. We'll hit open and upload. And while that's uploading, if we go back to Visual Studio Code, you can see here's the example. This is the same sample we had during our slides when we talked about logical partitions and documents within there. So we'll go on ahead and we're going to take this same file and then we're going to update the city to Paris. So let's go ahead and do a file, save as, we'll call this city2. Save it, and now if we go back in here and we're going to go ahead and upload city2, open and hit upload, we can see both files have been uploaded. So let's go ahead and close this. If we do a refresh, you can see now we've got the two files. We've got Chicago as well as Paris listed. We now have our database account created. We've got our database as well as the container created. We've also uploaded a couple documents as well.